Have you ever looked up at the night sky and felt a sense of wonder? A feeling of smallness in the face of cosmic grandeur? Now imagine the Egyptian desert and a mountain made by human hands, the Great Pyramid of Giza. It has stood for over 4,500 years, a silent witness to empires and shifting sands. For centuries we've asked a simple, profound question. How did they do it? How did a civilization without modern machines, steel, or electricity build the most massive, precisely aligned structure on Earth? This isn't just a question about engineering, it's about us, about human potential. The mystery has spawned theories, practical and fantastical. Some say lost advanced civilizations or visitors from another world. It's easy to see why. The pyramid holds over 2 million stone blocks, some as heavy as several cars. They're fitted with a precision that would challenge builders today. But claiming anything other than human ingenuity underestimates our ancestors. The answers aren't in the stars, they're written in the stones themselves, in the desert sands, and in the clever minds of the ancient Egyptians. To find the truth we travel back not by spaceship but with the scientific method. We will use archaeology, geology and physics to peel back myth and reveal the construction story. We'll become detectives hunting clues left thousands of years ago. Clues appear in ancient papyrus scrolls, in tool marks on the stones, in the remains of the workers' village, and in the very design of the pyramid. Before we can understand how it was built, we must first appreciate why the Great Pyramid is such a marvel. It was not the first pyramid ever built in Egypt. The Egyptians had been practicing for centuries, starting with simpler structures called mastabas, rectangular, flat-topped tombs. Then came the architect Imhotep with a revolutionary idea. He stacked several mastabas on top of each other to create the step pyramid of Djoser. This was a giant leap forward. Later pharaohs tried smooth-sided pyramids but ran into problems. Some collapsed. Others were built at the wrong angle. Those were prototypes, necessary learning experiences. The Great Pyramid, built for Pharaoh Khufu around 2560 BCE, was the culmination of that trial and error. It was the masterpiece. For nearly 4,000 years after completion, it remained the tallest man-made structure on Earth. Its original height was about 147 meters, roughly a 40-story building. Its base could hold several football fields. It's a symphony of numbers, geometric precision that still baffles us. What sets it apart is incredible accuracy. The four sides of its base are almost perfectly equal, differences of only a few centimeters, and it's aligned to the cardinal directions, north, south, east, west, with astonishing precision. How did they do this without a compass, GPS, or satellite imagery? They used the stars. By tracking stars across the night sky, they found true north with remarkable precision. That cosmic connection is built into the pyramid's foundation. Building a mountain of stone requires more than just muscle. It requires a brilliant mind and a detailed plan. The construction of the Great Pyramid was one of the most ambitious projects in human history. Its success began long before the first stone was ever laid. It started with a vision from the pharaoh, brought to life by an army of architects, scribes, managers. The chief architect, possibly Khufu's vizier Hemiunu, oversaw every aspect, the ancient equivalent of a NASA mission director. Responsible for a massive budget, a huge workforce, and a timeline that spanned decades. The first step, choosing the perfect location. The Giza Plateau was ideal, solid flat limestone bedrock to support enormous weight. A weak foundation would have doomed the project. The location was on the west bank of the Nile, symbolically, the land of the dead. Proximity to the Nile was practical too. Once the site was chosen, surveyors got to work. Their precision was extraordinary. To create a perfectly level base, they may have used an ingenious method. Build a low mud wall around the perimeter, flood the interior with water, mark the water level to get a perfect line. Cut the bedrock down to that line, leveling 13 acres to within centimeters. They aligned the pyramid to the cardinal points using celestial observations. For a long time, the popular image of the pyramid builders was different. It was thousands of slaves, driven by the lash under the hot sun. Hollywood helped fix that dramatic picture in people's minds. But the evidence tells a different, more impressive story. The builders were not slaves. They were skilled Egyptian workers. Some were permanent employees, master craftsmen, architects. Many were seasonal laborers. They worked when the Nile flooded their farms. It was a form of national service, citizens contributing to a sacred cultural project. Archaeology gives us a window into their lives. Just south of the Giza Plateau, archaeologists excavated a city for the workforce. artist reconstruction of the village, houses, bakeries, breweries, workshops, a well-planned community that could support thousands. Food remains show the workers were well fed, bread, fish, meat, far better than the rations of a slave. The state invested in their well-being. Healthy, motivated workers are productive. Skeletons from nearby cemeteries tell us more. Forensic analysis shows men and women did hard physical labor, signs of arthritis and strained muscles from moving heavy stones, but also evidence of medical care, healed bones. These are not signs of a disposable workforce. They were cared for and part of communities. They took pride in their work. Teams with names like Friends of Khufu, Drunkards of Menkora, Not Oppressed, a collective national effort. A pyramid is, at its heart, a mountain of stone. So, where did all this stone come from? The builders of the Great Pyramid were masters of logistics, and they sourced their materials from several different locations, choosing the right stone for the right purpose. Local Giza limestone, Tura limestone, and Aswan granite. The vast majority of the pyramid, its inner core, is made of yellowish limestone blocks quarried right there on the Giza plateau. This was an incredibly efficient choice. By quarrying the stone needed for the pyramid's bulk just a few hundred meters away, they saved an enormous amount of time and effort in transportation. You can still see the massive scooped-out areas today, a testament to the colossal amount of material they removed. The tools they used to cut these millions of blocks were simple yet effective. They did not have iron or steel tools, which came much later. They used copper chisels. They used copper saws. For harder stones like granite, copper tools would be almost useless. So they used a harder stone called dolerite to pound the rock into shape. They would also cut channels into the limestone, insert wooden wedges, and then soak the wedges with water. As the wood absorbed the water, it would expand with immense force, cracking the stone along the desired lines. For the outer casing of the pyramid, which is now almost entirely gone, they wanted something special. They used a fine white limestone from a place called Tura, located across the Nile. This Tura limestone was renowned for its purity and brightness. When polished, it would have made the pyramid gleam brilliantly in the Egyptian sun, like a giant jewel in the desert. These casing stones were transported on large wooden boats down the Nile, and then brought to the construction site via a system of canals and harbors. The Diary of Merer, an ancient logbook found in 2013, provides a first-hand account of these very journeys, describing how his crew transported limestone from Tura to Giza. Finally, for the most important structural parts of the pyramid, like the king's burial chamber and the massive lintels above it, they needed something even stronger. They chose red granite. This incredibly hard stone was quarried in Aswan, more than 800 kilometers to the south. Some of these granite blocks weigh over 50 tons. Imagine the challenge: quarrying these monstrous blocks, dragging them to the river, loading them onto barges, sailing them down the Nile for weeks, and then unloading them at Giza. This part of the operation was a monumental feat of engineering in itself, demonstrating the incredible power and organizational skills of the Egyptian state. This is the multi-million-dollar question. How did the ancient Egyptians get millions of heavy stone blocks, some weighing tens of tons, all the way to the top of a 147-meter-high structure? This is where speculation often runs wild. Science, archaeology, point towards ramps. The debate isn't if ramps were used, but which kinds. There are several leading theories, possibly combined as the pyramid rose. One popular idea: a long, straight ramp. Problem: it'd have to be incredibly long to keep a manageable slope. To reach the top, it would be over a mile long, using more material than the pyramid. Another idea: a ramp spiraling around the outside. It lets builders keep extending upward without an insane length. It would allow multiple teams working on all four sides. A variation: an internal corkscrew ramp. Physicists and architects have proposed a ramp inside the pyramid's outer layers. It's efficient, built from the pyramid's own blocks and not removed later. Modern scans have detected anomalies and voids that might point to this. Regardless of design, moving the blocks was brute force plus intelligence. Blocks placed on wooden sleds, workers pulled the sleds up ramps. To reduce friction, they likely poured water on the sand. Ancient Egyptian art depicts this technique. It wasn't magic, it was physics. A team of strong, organized workers using simple machines, levers, sleds could systematically raise a mountain of stone. The Great Pyramid we see today. Rough, sand-colored, stepped core. It is a skeleton of the original monument. When it was first completed, it looked completely different. The final stage of construction was to encase the entire structure in highly polished, brilliant white Tura limestone. These casing stones were cut with incredible precision. They were fitted so perfectly you could not even fit a knife blade between them. This outer shell would have been smooth and seamless, forming a perfect pyramid. Imagine what that must have looked like. In the intense Egyptian sun, the pyramid would have gleamed with dazzling white light, visible for miles in every direction. It would have been a beacon, a symbol of the pharaoh's divine power and a connection to the sun god, Ra. At the very top, the pyramid was crowned with a capstone, the pyramidion. That capstone was possibly made of electrum, a natural alloy, gold, silver. As the first and last point to catch the sun's rays each day, this golden peak would have shone like a star, connecting the earthly realm with the heavens. It must have been one of the most breathtaking sights in the ancient world. Unfortunately, this magnificent white casing is almost entirely gone. In 1303 CE, a massive earthquake struck the region, loosening many casing stones. Later, rulers and builders in the growing city of Cairo began to quarry the fallen stones, and even strip the remaining ones from the pyramid itself to build mosques and fortresses. It was an ancient recycling project. While it's a loss for us, it's a testament to the quality of the stone and the builder's craftsmanship. A few original casing stones can still be seen at the base of the pyramid. The work wasn't finished once the last stone was in place. The sheer scale and precision of the Great Pyramid have made it a magnet for myths and fringe theories. When faced with something so extraordinary, it can be tempting to reach for extraordinary explanations. One of the most persistent myths is that aliens built the pyramids. The idea is that ancient humans simply were not smart enough or technologically capable of such a feat. But this idea does a great disservice to our ancestors. It robs them of their genius and their hard work. Every aspect of the pyramid's construction can be explained through the ingenuity of the Egyptians using the tools and knowledge they had at the time. Another popular set of myths revolves around secret knowledge or lost technologies. Some propose that the Egyptians used some form of acoustic levitation or advanced concrete to cast the stones in place. While these are fascinating ideas, there is simply no evidence to support them. We have the quarries where the stones were cut, we have the tool marks on the stones, we have the sleds and the remains of the ramps. The evidence points to physical labor and clever engineering, not to a forgotten magical technology. The truth that humans accomplished this with simple tools and a deep understanding of mathematics and logistics is far more impressive. Science has been our most powerful tool for debunking these myths. Modern archaeological techniques like radiocarbon dating have confirmed the age of the pyramid, placing it firmly in the reign of Khufu. Geological analysis has traced the stones back to their specific quarries, and new scanning technologies like cosmic ray meography are allowing us to peer inside the pyramid without drilling a single hole. It was this technology that led to the discovery of the Big Void in 2017, a large, previously unknown chamber above the Grand Gallery, whose purpose is still being debated. These discoveries replace speculation with data, bringing us closer to the real story. By sticking to the evidence, we can construct a story that is not only true, but also celebrates the incredible achievements of the ancient Egyptian people. Today, 4,500 years after its completion, the Great Pyramid of Giza continues to hold a powerful grip on our imagination. It stands as a silent, colossal reminder of a distant past. Yet its presence feels as immediate and awe-inspiring as ever. It has survived earthquakes, it has survived wars, it has survived the relentless passage of time. It is a bridge connecting our modern world to the dawn of civilization. When we look at it, we are not just seeing a pile of stones, we are seeing a monument to what humanity can achieve. It embodies the audacity to dream on a cosmic scale, and the persistence to turn that dream into a reality that would outlast empires. The legacy of the Great Pyramid is not just in its physical form, it is in the knowledge it represents. It is a masterclass in project management. It is a masterclass in mathematics. It is a masterclass in astronomy. It is a masterclass in engineering. The skills developed to build it were passed down, influencing architecture and science for generations. The pyramid builders were pioneers. They solved complex problems with the resources they had, pushing the boundaries of what was thought possible. This spirit of innovation connects the architects of Giza to the engineers who build our skyscrapers, and to the scientists who send rovers to Mars. The pyramid also serves as a powerful lesson in perspective. In our fast-paced world of instant information and disposable technology, it is humbling to stand before something built to last for eternity. It forces us to think about our own legacy. What are we building that will speak to our descendants thousands of years from now? The pyramid is a testament to long-term thinking, a culture investing in projects a single generation would never finish. It shows us that with a shared vision, careful planning and a lot of hard work, there is no limit to what we can accomplish. The Great Pyramid does not need myths about aliens, nor does it need tales of lost technologies to be amazing. The truth is its greatest marvel. It was built by people like us, and that is the most inspiring story of all. It is a story written in stone, for all time.